Welcome to this video where I'm going to show you a tutorial on how to make shapes like this that you can see in my little digital ant farm, procedural terrain, or any kind of shape. I've used it for not really terrain but ledges here. So it's a kind of randomly generated terrain but not quite random. It's not quite random. It's something that you haven't designed. So in that sense, it's kind of automatic, synthetic, not kind of user generated, but is a nice surprise, something that you can discover. So you can make it like a game where you're exploring truly and finding new shapes and undiscovered countries, that kind of thing. But what I wanted to do is something not as elaborate as that. I just wanted to make like a nice floor to this little digital ant farm. So I've got ledges going on, but I'd like to use Perlin Noise to make just an interesting floor of this digital ant farm thing. So let's just I'm going to bring up like a little program that I wrote the other day. There we go. So I can type, but it'd be a bit more interesting to watch. So I want to make some like procedural terrain, procedural terrain, and I'm going to do that by using something called Perlin Noise. Perlin Noise. Very, very nice. Right, Perlin Noise. So what is that? It's something you can use to create, instead of having, say, terrain that goes up and down, like kind of randomly, you can have much more smoother, natural looking terrain. And also, so you can, what shall I put? I can put Perlin Noise because this can generate more natural looking terrain, and Perlin Noise can be seeded. Seeded. So if you're wondering what that meant from maybe like Minecraft or something like this, what does it mean to seed your terrain or seed anything? What that means is we can put in a number, a unique number, and then every time that terrain or whatever it is generated, it will be exactly the same. So that means if you find a nice seed that you like, say your birthday, something like this, you could use that number again and again to create reliably the same terrain. So if I'm creating a nice terrain, have I still got it running? No. Let's run my little digital ant farm again. So I could make a nice procedural floor for this digital ant farm, and if I liked it, then I could put in that seed again and have exactly the same. Or I could randomly choose a seed if I wanted a random floor. But what Perlin Noise therefore gives you is this control over random-like objects or random-like structures such as a terrain. So let's get going. So I'm going to do this in JavaScript, but it would work in the principles would work in any programming language you're using. So where do I need to go? I need to go in my main JavaScript file, which is called Blinky Farm. I've also called those little creatures blinkies because they kind of blink. And I am going to do this from scratch. So I've got setup environment here, and this is where I'm creating those different ledges. So I'm going to use the same kind of technique as here. So what I might do at the bottom of this function, I might then create a new function called generate floor. There we go. So I'm going to generate the floor. What is the time? So it's about 6:30. So I'll go no more than half an hour, something like this. Right. Function generate floor. There we go. Right. So what do we need to do? We need to essentially create a load of boxes at the bottom, and then we're going to, let's do that first. We want to create a line of boxes, and then later on we're going to do the procedural Perlin-y stuff to to make them look like some rolling hills. So first, let's just get some boxes across the floor. So let's say, we'll call it a brick. We'll call it a bruck. So these boxes are going to be called brucks. So let bruck width equal, in fact, we don't want to vary this, so we'll make a const, which we can do in JavaScript now. Right, const bruck width equals, I don't know, let's start with 10. Now we need to calculate how many brucks we can fit in the entire length of the screen. So what we now need to do is say bruck amount, so we'll call that b amount, or number, we'll call it number, bnum equals the width of our screen. So I'm using a library called p5, and in p5 you can use the keyword width, and that will simply return you the width of your screen. So whatever language or environment you're using, width, you need to generate that if your library's not doing it for you. So width divided by our bruck width. There we go. So that tells us how many boxes we can fit in there. Okay, so now we need some kind of for loop. So you know what we should do? We should start at 1 and consider that to be the first brick. There we go. So while so we're going to go around this for loop while I is less than our bnum. Less than equal to. I hesitated over where to start there, because usually if you're working with an array in programming, you start at 0. I don't know why I'm starting at 1. I've just got a feeling. I think I did it with the ledges, so I'm going to do it here. Anyway, and then I++, of course. Right. So we just want some boxes. So in P5, you could use rect to then draw a box at whatever location you've got. But what I've generated here, I've already programmed a method for creating a new object and then giving it a position. So you could do something similar. You could simply be drawing these boxes, or you could be working with objects that you've got in your environment, maybe in Unity, something like that. So how do I do that here? Red hen 2D physics, that's the name of my wrapper, and I want to create a new object, and I would like it to be what do I call it, a rectangle? I forgot what I call it, a rectangle? Well, actually no, it's just going to be a box. They're going to have the same height and length, right? So box, and now I think we put in the position. So our position is going to be I is going to keep getting up longer and longer. So we're talking about the x-axis here. So as I gets bigger, we want to do I times the width of each brick. So brick 1 is going to be 1 times 10. Then brick 2 is going to be at 20. And so they'll be spaced exactly the right amount apart. You know what? It would be nice now to start at 0, because then the first brick is going to be positioned correctly. Because actually I don't want it at, I'll stay with 1. Let's just let's just go ahead. So I times bruck width. Okay. Now at the very bottom of the screen, so that's going to be height, which is again a P5 keyword to give me the bottom of the screen. So height minus, let's go bruck width. We could do half of the bruck width or something like that. Bruck width, and then so I've asked for a new box. I've given it its X location, its Y location. Now I believe I just need to put in the diameter, or do I use a radius? I can't remember my own wrapper. Let me just go and have a look. What am I asking for? New object box. So I'm just looking for the constructor for this box object. So it's probably radius. It's probably radius. Let's just go back. Right. And that's going to be Bruck width, of course, divided by 2 if it's a radius. Oh, I had a little bit of a lisp in my voice there. Bruck width. Right. Let's just see if that works. So far, I'm calling the function. We should get some bricks at the bottom. I can't remember what color. Are they going to be pink? Ah, yes. They're pink. Lovely. So they're being drawn at the bottom. Oh, also they can be knocked around. Okay. Also, I'm getting a bit of lag because I'm recording the screen and stuff. So let's just make my program a bit simpler. And at the beginning, I'll only create one of these creatures. There we go. Create one creature. And let's make those bricks a little bit higher. So I'm just going back to the function. Oh, sorry, I missed the function. Where are we? Generate floor. So a little bit higher. So let's just do the height minus 42, a nice number. And let's just have a look at those again. So this should run a little bit more smoothly now. Yeah, that's a little bit quicker. Oh, they drop down, of course. They drop down because they're not static. So I'm creating objects that are not static. So I just need to ask my program last object created dot make static. Okay. And let's just make our width a lot bigger, 40. And just see what's going on. It looked like there was a gap between my bricks, so I don't think the basic technique is working. So, what am I doing? I need to sort this out a little bit. But there we go. We've got a number of bricks starting in the wrong place. But they are now static. That's good. Okay. So let's start at 0. So what will that do to the x position? That means it's going to be for the first brick, 0 times a brick width, which is going to be 0. Anything times 0 is going to be 0. So it's going to be positioned kind of halfway off the screen. So let's plus ruck width divided by 2. So now let's just check that. So we should have at least our first brick precisely on the screen. No, I'm getting mixed up with something. Sorry, I'm really holding back. I'm holding up the time here. What am I doing? So let's just try it. 0 times bruck width. This shouldn't be flush. Yeah, that's what I'm expecting. So plus, I think it's to do with, maybe it's taking a diameter here. Let's just try this. So plus bruck width divided by 2. Oh yeah, also the big problem was the bricks were not together. So now they're together. So I think actually when I was creating the brick, I was creating it with the wrong dimension. I was creating it with a radius, thinking it was a radius, in fact it was a diameter. Okay, so we've got our bricks and they're fitting precisely across the screen and everything. Right, so that's something that everyone would have been able to do on their own. And so it took me a little while. Okay, so now we need to apply this Perlin noise. Right, let's just go back to our instructions. Right. Okay. So Perlin noise. This was invented by a man called Ken Perlin in God, it was something like 1982, something like this. And he now works at, I think it's New York, NYU. I think it's New York University. And I think it was, this might be apocryphal, but he was working on the Tron film, and they wanted you to generate some graphics that, as I said before at the start of the video, which needed some kind of randomness in, but also some naturalness to it. And so essentially what you do, there's a function, usually called noise in many programming languages, or it might be math noise, something like this. And once you call that function, it will give you a number back between 0 and 1. Okay. You also have to pass in to the function a number. Okay. And so let's think about our bricks. I'm going to put in a number for the first brick, the second brick, the third brick, and the fourth brick. So depending on what number you put in to the noise function, that will influence what number between 0 and 1 you're going to get back. And the way it differs from, let's say math.random, because math.random will give you a number, in JavaScript anyway, between 0 and 1. But what noise does, it relates what number you're getting out to that number that you put in. So if you're putting in I and then I plus 1, I plus 2, I plus 3, those numbers will kind of control how different the output is going to be from the previous one. So whereas random would give you kind of like this number, 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 Perlin Noise, because you put in a slight increment, it will give you this number, this number. It can go slightly higher than the one previously, slightly lower again, slightly higher. So it can only differ by a certain amount from what it previously outputted to you, depending on what index you put in, what number you put in. Okay, so let's demonstrate that. Let's do it. So back to the code. So what do we want to do? We want to influence the I position of each of our bricks. Sorry. There we go. So, oh, everything's pink. Isn't that lovely? So by the way, I can control this little blinky. So I've gone down the bottom. We can control the Y position. And so the X position is going across. So that was useless. Sorry. Let's do that. So we want to change height minus 42, and then we'll minus, and we'll call this. Let's just call it Ken's number, after Ken Perlin. Some respect to Ken Perlin. Right. Okay. Ken's number. So let's just make that variable up here. We're going to say let Ken's number equals 0, and then each time we go around the loop, we're going to say Ken's number equals, here's our noise function, and what we're going to put in there, we're going to put in I, and let's just see what we get. We haven't done anything else yet. I'm curious. I don't think there'll be much difference. There is actually a difference. If you if you lean in here, we've yeah, there's a slight difference already. So the question is now, how do you control procedural, or rather Perlin noise, in order to give you interesting procedurally generated terrain and things? So there's two things you can do. You can use a scalar, so we can times by an amount. And let's call it the amplitude. Because if we're thinking about a wave, the amplitude is kind of how much it can go up and down. So let's give ourselves another constant value. So const, we'll call it floor amp. Floor amp equals, let's start with 100. There we go, start with 100. So we're going to scale up that number that's always returned between 0 and 1 times 100. So the biggest amount it can be is 100. The biggest number we can get back from the noise function is 1, times by 100 is 100. Right, there we go. Let's, oh, sorry, I supposed to put the constant name there. Right, let's have a drink. Okay, so we've got it going. Right, let me refresh. Oh, that's interesting. I thought it was going to be different every time. Oh, I know why it's not different every time. These, I'm already, let's explain the next thing, seeding. Seeding. With Perlin Noise, let's go back to my, kind of like my whiteboard. Right, by the way, all these letters flying around, they're deleted letters. They're like the ghosts of mistakes and typos. Right, so Perlin Noise. Perlin Noise can be seeded, as I talked about before. Now that's a way of kind of like saving a nice terrain that you like. And in P5, to seed the noise, do I write noise seed? I think I write that. And then in parentheses, you put in your seed. And I love this idea. It's a number that kind of acts like a seed that grows into a specific part of the Perlin terrain, if you like. And basically, what is Perlin Noise? Perlin Noise is like a pre-generated map of hills. It's already there. And what you're doing when you ask for a new seed, you're just finding a location on that map. So if you have the same seed time and time again, you're finding the same location, the beginning point, and then the numbers you're getting back are predictable. They're going to be from the same place. So if you wanted a random starting point, so new terrain each time, you need to randomly generate a seed number. So in here we could say math.random times, I don't know, 100. So we're getting a number between 0 and 100 approximately, and that's going to be our seed. So let's just put that into our code, and we should get a different terrain each time at the bottom. Our terrain is looking rubbish at the moment. We need to fiddle around with the amplitude and things like that first. So noise seed, math random, I'm going to scale up that number. Remember, math random returns a number between 0 and 1. I want to scale up that to, let's have 1,000. So we've got 1,000 different terrains. Hopefully I've remembered the correct function name, noise seed. I think that was it. Okay, so we've got a new terrain at the bottom. Refresh. Refresh. Yes. So now you can see we've definitely got new values for the Perlin noise being generated. So the amplitude is going to be the same. So it's going to look the same in terms of the degree of variation, but it will always look completely different. Also notice my ledges here, which are generated using a very similar thing. They're not changing in their shape because they're being seeded with, I think I've used seed number 9. So they're already being created before I mess around with the seed again. Although you can see these little imperfections that I'm randomly generating. So I have no control over that randomness. But let's sort out this terrain. First, we need to make these a lot smaller. We'll change their color. And we can fiddle with the kind of the gradients and things like that. So we've got our new seed. Well, let's put in a constant seed. We'll put in seed 1, 2, 3. but we need to make our Bruck width, so that's our block width. Let's make that a lot smaller, so a quarter of the size, if I'm talking about the diameter. And let's just have a look at that at the moment, because the issue might be they are being asked to kind of vary too much, and so you get this broken, very unsatisfying kind of look. And also what I'm going to do, I am going to stop generating my ledges. Let's just see if I can do that so that we're not distracted and we're only focusing on the floor. So that hasn't broken things, good. Okay. So we've got to mess with the gradient. So we can say the amplitude is maybe fine. In fact, let's even increase that. Let's say you can go as high as maybe the height of the entire window or canvas divided by 2. So it could go as like over halfway up the screen, because I'm not drawing right from the bottom of the screen. Let's just have a look at what that looks like. Okay, so this would look really cool. So we've got, you know, hills going right up there. Okay, but what we want is we want each block not to be able to, these two blocks are okay, so we'd want this kind of thing to happen, but then the next block can move all the way down. So really, we never want that block to be able to move more than an entire block's width, so Bruck width. So what we need to do is, I think it's called the gradient. We want to have a finer gradient. So let's have a look back at our noise function. So inside noise, you put in a number that you're kind of generating in terms of a list, so that each time you call the noise function, you're going along, say in the case of me, some blocks that are meaningfully related together. Then you scale that return number by a number that will now represent the kind of amplitude of your wave. So how do you get a gradient? What you do, you times, or multiply, you multiply the number that you're putting in to the Perlin noise. And we kind of want to get a finer, smoother gradient. So we're going to have to go less than 1. So let's go 0.01. Now that might give us kind of like a straight terrain. Like not enough difference. We'll have a look. Now, this is now looking very attractive. So we've got a nice smooth gradient. So let's try again. You know what would be really nice and satisfying for you guys to watch is if I just wrote a little function that called generate floor. I'll try and do that, right. So in P5, I can write mouse pressed. Hopefully I haven't used this somewhere else in the program. Mouse pressed, and then I can call generate floor, and that will create a new function. That will create a new terrain for us, but it's going to look exactly the same. So we could pass in there amplitude, and we want this now to be a variable. And the first time we create it, let's say height divided by 2, so that was the same. So every time we press it now, we can have a different amplitude. So let's say a random number, math random. Oh, what I wanted to change was the kind of the fine tuning. we could do both of them. So gradient times height divided by 2, or whole height maybe. Okay, and then we want to put in also the gradient. Let's put a t gradient. Again, let's have that increase. So we'll start with t grad equals 1. So start with 1, and then we'll have t grad plus equals. So we'll have it. Oh no, we'll go by a factor of 10. So let's try that. So our gradient is getting smaller and smaller. Right. So in here, amplitude is the first one. So I really want to keep that constant now. Damn it. So let's just keep that to height divided by 2. Although it's nice that we've got this functionality for later on. And that's going to be a gradient. So we want to put, where do we want to put in the gradient? Ah, here. So grad. Is it underline grad? Thank you. Thank you, editor. Okay, so we've got our gradient now. Every time we click. Right. Mouse press gradient. Yeah. Okay, so first time it's generated, it should look. I can't remember. No, that's terrible. Has something gone wrong? No. What am I doing? Mouse pressed. Oh, I might be using this somewhere else. Oh no, it did work though. Mouse pressed. Oh, times equals. Sorry. Oh, right. When we first called it, we want the gradient to be, or t grad really, but let's say 1. Okay. So now every time we click, yes, we get the gradient decrease, decrease, decrease. Okay, so it looks like a mess. What I need something a bit more sophisticated to kind of like delete the previous load. Maybe we can decrease a little bit slower than that to show you the idea. So our gradient is 1, so we're not changing anything. We're just multiplying I, so that number that we put into the Perlin Noise function, by 1. Next time we make some, so I just clicked accidentally there. Next time we create some, we've changed the gradient, not the amplitude. The amplitude is staying the same, which is this height divided by 2. So the highest we can get is here. It's not surprising that the highest peak we're getting is about there. But now we've kind of decreased that gradient. You know what I could do? Oh, are they the last things to be created? No, this blinky is. I'm just trying to see if there's a way using my pre-existing code to delete those. To delete those bricks to replace them would be kind of cool. Anyway, what I thought of doing, I could change their color. Maybe. Let's have a look. So that's the last one created. Dot color. No, fill equals. We wanted them to be green anyway, so 0, 0, 0. Green in the middle. So we're going to say, this has got to be related to the the gradient. So we'll say grad, can I just say 255 divided by grad times, that's going to decrease it by a lot. Oh my goodness. Let's just, let's just see what this looks like. Yeah, they're all going to look the same. Brilliant. So each time I'm clicking, I'm decreasing the gradient. This is turning out to be kind of a useless diagram, but they are getting darker actually, to be fair. But still, you can't really see see a nice diagram of change. But I had to click it about 10 times there. So let's go. Let's say let's stop doing this. We'll only create them once. And we'll say our gradient equals 0.1. There we go. So that looks kind of cool. So there's a little bit of a problem here. So the gradient is not bad, but it's still not good enough. So we want to go even less. So we'll go half that and see what we get. It's almost okay. It's almost okay. So I need a bit smaller. And you'll see there'll be when you're fine-tuning this, just as I'm doing now, there's a relationship, of course, between the amplitude and the what I'm calling the gradient. The bigger the amplitude, and the more if you're using kind of like voxels and things like this could just represent points. So if you're in 3D, it might be vertices that are being controlled. It might be the y direction for your vertices, and so you would anyway have a continuous like what I'm trying to say, a continuous plane between those vertices anyway. So you would have less of a problem. What would look good now is if I generated some boxes underneath here. So let's just try and do that. I mean, in my real program, I'm going to probably keep this. I'm going to tidy up and refactor the code, but I'm going to have this for my floor in my digital ant farm. But instead of like actually creating all these objects underneath, I'll probably just draw them in once, maybe save that as an image, and then have that recreated. So then I wouldn't have all the collision detection being kind of called in every frame. Right. So let's just see if we can add to this. So in our loop at the moment, we're just creating one layer. So we need kind of a nested loop. We need to generate this box a number of times. So let j, this time we've done I, so let j equal 0, and while j is less than the number of layers that we want, I'll call it b layers, j++. Okay. So what are we doing? We're just adding an amount to the y position. And I'm going to add that, and it's going to be a multiple of the Bruck width, we called it, because they're just squares. So we're going to multiply what layer we're on by Bruck width, and we'll go down how many layers we need. So I just made a variable called, where are we? B layers. So let's do that. So const b layers equals, now you could be very clever with that, and you could say, well, how far am I from the height? Calculate how many bricks you need to fill up that gap, and then only do that number of layers depending on what position you are across the X. You haven't got time for that to watch me try and work out the maths and logic there. So I'm just gonna put about about 12 bricks down underneath each brick, and that will do. Right. So now each brick is getting 12 layers, but we've got to change what's happening with the Y. So in our new object box call, this controls the X position of each box. So that needs to stay exactly the same. That needs to stay the same. All we need to change is this parameter. This parameter. So we're going to say plus, because in the Y, on the Y coordinate scheme, 2D graphics, Y gets bigger as you go down the screen, plus, and we said a multiple of bruck width. I really wish I hadn't called it bruck width now. I find it really hard to say. Bruck width times what layer we're on. And if we're starting at layer 0, it will just be 0. I think is that a good thing? No. Is it? Yes. Yeah, it's fine. Right, bruck width times J. That's what layer we're on. I think that will work already. I think that's all we had to do. Yes, look at that. It's now running fantastically slowly. Oh, look at that great collision detection. Because I'm creating so many bricks, and look, I needed a few more. There we go. What would also look kind of good is, of course, let's have a few more layers. Well, let's not make them so high. Height minus 42. I'll just say height minus bruck width size 12. That'd be kind of good. Bruck width. No, we'll just say 10. Just say 10, something like that. And then I should have kept this as right. What am I doing? 10 minus what was I doing? Oh yes, I wanted to vary the color of each brick. So times kind of its height. Times what layer it's on. There we go. That would look kind of good. So I think that will look okay. Okay, there we go. And every time we run it, we get the same. So let's just demonstrate the final thing. How am I doing? Oh my god, it's gone about 45 minutes. Right, let's just have a look at seeding something different. So that was noise seed 123. Let's put in 999 and see if we like that terrain better. That Perlin generated terrain. Ah, interesting. So it's a lot higher. So in terms of the whole scheme of where that is, it starts off in a much higher position. That looks really cool. I like the double thing there. So what you have to think about is where you're positioning the whole thing in terms of what seed you're putting in. And this is kind of bad because let's say I wanted the user to get like a random seed. Now they might get something I'm not really expecting where they're starting really, really high according to that random scene, whereas in my own version I'm just using like a seed that I use every single time. Just in the development it might look great. I might have it exactly covering the bottom of the terrarium or the digital ant farm or whatever, but it's not looking okay when a user uses it. So I don't know, you need something more thought from that. But anyway, I hope you enjoyed this video. I hope that was useful. That's what Perlin Noise does, and that's how to generate procedural terrain, amongst other things. There we go. I'll put a link to the GitHub where you can get this code and use it yourself. Thank you very much. Thanks for watching.